I've spoken a lot about untrusted data in my previous Pluralsight courses, but I want to recap it here before we proceed with the module, because it's assumptions about untrusted data that's going to bring this demo app undone in the examples we're about to look at. Now, frequently, when I talk about untrusted data, I talk about it in the context of things like SQL injection and cross-site scripting. And it's usually because applications are designed in such a way that they're not expecting data sent by the user to be malicious. Now, untrusted data comes about when, first of all, we can't verify the integrity of it. So we don't know if data sent by the user may have been manipulated. Consequently, the intent of that untrusted data could be malicious. A user could send a request to the server that has malicious payloads such as SQL injection. I mentioned cross-site scripting. This is a perfect example of untrusted data being used to exploit a system. Another one that might be a little bit more obvious is things like a binary. If you allow someone to upload a file to a server, you'd have to assume that it could contain malware. That would be the only responsible assumption to make. Of course, most of the time it won't, but you have to cater for those scenarios. But of course it begs the question, where does this untrusted data come from? I mentioned that the user sends it to the server. How do they send it to the server? Let's take a look at that now. Here are a few very common sources of untrusted data. So a really obvious one is when the user sends untrusted data to the server via a query string. It's untrusted because the user can modify it, so consequently we can't have confidence in the integrity. Not unless it contains something like a message authentication code as well, which is not usually the case. So a really classic example, we often see a reflected cross-site scripting attack by virtue of parameters in the URL being changed. You can see examples of that in my Hack Yourself First course and in my OWASP courses as well. Another classic source of untrusted data sent via the user is in a form. You can't control what the user enters into a form. Yes, it's normally going to be, say, their first name and their last name in a registration form, but it also could be a SQL injection payload. You have to work on the assumption that that will happen and cater for that worst case scenario. Another one that people often don't think about in terms of trusted data is information that's sent implicitly via the browser. Cookies are a great example. Under normal circumstances, a user doesn't directly change their cookies. That's something that the web application sets. But of course a user could change their cookies. They could edit it in the browser using the developer tools, or they could go and recreate the request in a tool like Fiddler or curl and modify those cookies to contain a malicious payload. Now, cookies are obviously sent in the request header, but there are other classes of data sent in the request header as well. Classes of data that the browser automatically sends. So, for example, the language of the client. I expect my browser to send EN-AU for Australian English when it makes a request, but if I'm building a web app, I can't trust that the language field in the request header hasn't been manipulated, because an attacker could change it. And again, they could insert something like SQL injection into that language field. So my web app needs to work on the assumption that the data could be malicious. Then, of course, there are other locations that are sources of untrusted data. If you consume an external service, it's untrusted. They could modify the content or the intent of that data. Even your own database, because your own database tends to be populated by sources of untrusted data. Form submissions, for example. So you're always working with the assumption that even the data in your own system already persisted in the data layer could be malicious. So hopefully that sets a bit of a scene in terms of untrusted data. And we're going to see examples of what goes wrong when untrusted data is not validated throughout the remainder of this module. Let's go and start looking at that right now, and we're going to kick it off by seeing what happens when we actually modify web traffic in Fiddler.